Hello guys. Today we are going to go over chapter 5, which is about the temperature of the atmosphere. And it starts out with this picture of our atmosphere that was taken from the International Space Station. And you can actually see the layers, a couple of the layers of our atmosphere. And it's because they're composed of different stuff. So just like, oil and water separate, different gases will also separate out just due to density and temperature differences. So down here, you can see all of the clouds are contained really close to the ground. This layer right here is the one we live in. It's called the troposphere. So all weather happens there, all life is in the troposphere. Above that, you can kind of see this white and then a little bit of a purplish layer here. That's the stratosphere. And in the stratosphere, we have that very important ozone layer that protects us from harmful UV radiation. And then above that, we've got the mesosphere, then thermosphere, and then out into the ionosphere in outer space. It says the atmosphere is layered, corresponding with how the atmosphere's temperature changes with altitude. Okay, so we have these different layers in the atmosphere that scientists gave different names, categorized them because of the significant changes in between them, and that significant change is temperature. This picture here shows, you might not even know what this is. This is a radiator. When I was your age, we had radiators in our school. It says papers are being held up by rising air currents above the radiator, and that is showing or demonstrating the important principle of how warm air rises and cold air sinks. Okay, so we have to kind of think back to 6th grade. In 6th grade, you guys did a lot of different labs and activities that had the little circles with the motion lines on them. What the purpose of those lessons was to show you that warm air or warm water, those molecules, move around really, really rapidly. Okay, and when they move around rapidly, they bounce against each other and they're widely spaced, right? They're really, really hyper and moving all around, okay? In a volume of cold air or cold water, the molecules huddle close together. And sometimes they are so close that the bonds will reform, and that's what causes freezing. Okay, so if you've got a container of air that's warm, molecules are widely spaced. And if you've got a container of cold air, more molecules are going to be tightly packed in there. It's going to be denser, and so it will sink in relation to the warm air. Okay, and that's a huge concept in weather when we study weather. The property that changes most strikingly with altitude is air temperature. We talked yesterday about how pressure also changes with altitude, right? The most air pressure is down at the ground because you have that whole column of air weighing down on us. So pressure decreases as we go up and it stays next to nothing all the way up into space. But temperature is not quite so simple. It goes back and forth for a variety of reasons. This graph right here is showing temperature along the bottom here from negative 100 degrees Celsius all the way up to 30 degrees Celsius. So warm here, cold here. And then this is altitude in kilometers from ground level all the way up to 100 kilometers above the surface. And you can see here in this lower layer, the troposphere where we live and where all weather and life is, the temperature is decreasing as we go up in the troposphere. And again, if you remember from the lecture yesterday, that's because the ground holds on to a lot of heat, right? As we move away from that heat source up into the air, it's going to get colder, just like being around a campfire in the spring or fall. And it's nice and toasty around the campfire. You back up from that and you can tell a very big temperature difference. Think of the ground as your campfire. Okay, so it gets colder as we go up until we get to this boundary right here that's called the tropopause. The tropopause is just the ceiling of the troposphere before we get into the next layer. And it's not like if you were rising up through the atmosphere, all of a sudden you'd hit the troposphere and hit your head. It's an imaginary line. It's just the boundary that scientists identified as the difference between the troposphere and the next layer up, which is the stratosphere. In the stratosphere, which is right here to here, okay, this is all the stratosphere, the temperature increases with altitude. So the further you go up in the stratosphere, the warmer it gets. And that's because our ozone layer is housed in the stratosphere, and that holds on to a lot of heat. We get to the top of the stratosphere, which is called the stratopause, and the temperature again decreases with altitude. And that's in the mesosphere. The mesosphere is actually the coldest layer, so it actually gets the coldest throughout the mesosphere until we get to its boundary, the mesopause, where the temperature switches again and gets warmer in the thermosphere. I'm going to attempt to show you a couple of my fantastic drawings on the board and see if I can explain it a little better. All right, so here I have 2 volumes of air. This one is hot, okay? And you can see that the air molecules, there are 6 of them, they're moving really rapidly, they're bouncing around, and they're widely dispersed, okay? So they're lofty. Here, same 6 molecules are moving slowly, and so they're densely packed. You could get more of them in this volume of air, and so it would be denser and it would sink. So in weather, we are always talking about how air masses are moving in relation to each other. So if these 2 air masses came into contact, this one is going to move above this one. That's a really, really important thing when we study meteorology. It's how air moves. That's called wind. That's what drives weather patterns. Okay, here I have the four layers of the atmosphere: the troposphere, stratosphere, mesosphere, and thermosphere. Down here, I've got my clouds drawn in here because all weather is occurring here in the troposphere. As we move up in the troposphere, the temperature, if we've got warm temperature here and cold temperature here, the temperature is going to decrease with altitude. It's getting colder and colder and colder and colder until we get to this boundary. And then it gets warmer with altitude in the stratosphere, and that's because of the ozone layer holding on to heat. We get into the mesosphere and it gets colder again with altitude. This is the coldest layer until we get to the top of the mesosphere, where it gets warmer again. Okay, so you can see that each layer has very different temperature trends. And again, that is why, that's the characteristic that scientists use to divide it into the separate layers. If we talk about pressure, again, just to review from yesterday, pressure decreases with altitude in the troposphere, right? Because most of the air is just weighing down on us in the troposphere. And once we get to the top of the troposphere, it remains at basically nothing all the way up, okay? So pressure decreases with altitude all the way up. Temperature goes back and forth. And that is the reason that scientists divided it into these separate layers. All right, so now you've got 6 questions. 6 questions that go with this video. Access the Atmosphere iBook, go to chapter 5, watch this video, and answer these 6 questions on your Atmosphere Google Doc, and we will move on from there. I hope that you are doing well.